In this video, we're going to focus on introduction to communication systems. So in the context of electrical engineering, when we are talking about communication systems, we are referring with the whole system that is used to transfer information from one location to another location. We use that all the time, from your cell phone to satellite communication, to network communication, to whatever, radio transmission, TV transmission, all of that kind of stuff is part of a communication system. So it's basically studying of the systems that take, as this diagram shows, is a study of systems that take information bearing signal from one end and produce same information bearing system on the other end as clearly and as truthfully as most consistently as possible. So that's our goal. Another name for the signal used this on the sending side, we sometimes call it the modulating signal. And then the receiving end, what we get is a modulating signal. So that's another name for the information bearing signal. Now we'll talk about why can't we just take a signal, for example, voice signal, why we can just take that, translate it to voltage and just transmit it right off the microphone, transmit it in the air or wire to the other side and receive it to the other side. We're going to talk about that in more detail later, but for now, just to say that once in a while we have to shape those signals. So the shaping of the signal is called modulation, so that it matches what our communication channel requires. But right now wireless is becoming big, so a lot of wireless communication, but conductive material like copper, coax, which is like the cable is carried on, and optic for really high frequencies transmission, we use optics, and many other things, satellite and other things, which is more air. And then once the signal is received on the receiving end of it, we have to take it back to the original set of signals, and that process is called demodulator. You may recall that when you go and get let's say a cable modem, they give you a modem, and the modem name comes from the fact that in it's built in modulation, because it's got to transmit things from your side, and then it also has a demodulation built into it. So therefore that's why the word modem is modulation, demodulation. So that's what it means when you get a cable modem, for example. Okay, so when you hear in the context of electrical engineering communications, what we are talking about is a study of communication system as it's laid out here. Okay. Now let's go ahead and talk a little bit about air, because air is one electromagnetic. Let's talk about actually electromagnetic spectrum. Everything we hear, everything we see, everything that gets transmitted, it fits within the electromagnetic spectrum, and that's what this graph right here is. This is called the electromagnetic spectrum. Okay. Now the way we talk about it, so wavelength, just FYI, wavelength is just a quick way of talking about, sorry, that's not it, here we go. So wavelength is just a division of the speed of light by the frequency of your signal. So if your frequency, the speed of light is 300 million meters per second, whatever your frequency you have, then it becomes lambda. So let's take a look at some of these things and kind of some of the names you've heard. And let's translate it to the frequency of the signal we are talking about, as well as the wavelength of the frequency you're talking about. As you can see, as the frequency goes up, the wavelength goes down. That makes sense, because the relationship between lambda was C over F. So the relationship between frequency and wavelength are inversely proportional. Okay, so like the radio, when you put your radio dial on AM, you're listening to a set of frequency that are 540 to 1650 or roughly 1.5 megahertz. If you're listening to FM, you're listening to things that go around 80 to about 110 megahertz. Okay, now these are frequencies, and we'll talk about why they are at those frequencies. Why can't they be at lower frequencies? And we'll have that conversation later. Then we got a whole bunch of color: infrared and ultraviolet, and they're based on what visible light is. Red is the bottom of the spectrum, that has the lowest frequency. Violet has the highest frequency, and those are the visible range. But as you can notice, the visible range occupies a very, very small part of the spectrum. The frequency of visible light is only from 3 to 7.5, 10 to the 14 hertz. Okay, so in other words, the visible light is at about 300 to 7,500 terahertz, 10 to the 12. And so you may have heard of ultraviolet light. That's above. We cannot see it, but it's above that. Then we have near and far range. Each one of these are used for a special kind of purpose. X-ray, we understand X-ray. The X-ray sits above the ultraviolet, and then we have the gamma ray. So X-ray. So if you go to the doctor to get your X-ray done, they're shooting you with waves that are in this range of frequency and this range of wavelengths. And this also attempted to give you kind of a scale of how the wavelength is. So in other words, one complete cycle of a wave at 3 times 10 to the 5 will take the whole height of Mount Everest to finish. If you get more closer to, and this should really be so if you get a little closer to, for example, frequency of 10 to the 7, 10 to the 8, which we're looking at 100 megahertz or so, the one single wave takes a human length to go up there. And as you go higher, it gets smaller and smaller as how long it takes for a full cycle to repeat itself. Now we come to a reason why we take our normal voice signal or other data, and we've transmitted, for example, the radio frequencies between 540 kilohertz to 1.5 kilohertz. That's because the atmosphere, the air we live in around the Earth, it has different resistance, or better term would be impedances, depend on where we are. So for example, the lighter regions have a very low Z, so very low, let's say approaches 0. The darker places, Z goes to infinity. So if I want to transmit something, I want to transmit it over a medium that has a very low impedance. So I would like to, if I have the opportunity, I would like to either be transmitting somewhere in this range or somewhere in this range. Okay, this up here would be optical frequency, and if you look at it, this corresponds very closely to what we are able to view. And this one, if you look at all the for example, the radio frequencies police uses, the television frequency, radio frequency, cell phones, wireless, and all that, you'll find that most of those fit very nicely in this radio frequency window, and that's why they do it. And this whole modulation we were talking about, for example, when we're transmitting in the air, modulation job is to take your signal and change its frequency to where it can be transmitted in a low impedance air. So that basically means the air will not suck up all the energy of your signal and let it travel a long distance without losing its value because the impedance is so low. Okay, so those are kind of this overview of communication system and what folks have to worry about. Let's go back here and put it in example, for example, of a speaker's voice. So in a speaker's voice, in humans, we know that humans typically, the human complete range is 0 to 20 kilohertz. That's a little bit of a misnomer because most of our even speakers can't quite get down to 100. Most of us are not able to vocalize much beyond 15 kilohertz, and we can't even hear it, so most of us. So the reality is the range is this, but in an ideal case, humans are capable to hear from 0 to 20 kilohertz. So you got this recording of whatever, and you want to transmit it. Now the question is, what happened to this thing? Remember, I would like to take it up to my transmission. Let's say if this is air, I really would like to be able to transmit it somewhere in the low impedance region. So that means I got to modulate it, and modulate it for what we're going to talk about here. Modulate it specifically is to kick it up to that. For example, if you want to go to an FM station, we would like this 20 kilohertz signal to be riding closer to somewhere between 80 and 110 megahertz. And the way we do that is we use our knowledge of Fourier transform and all that to do that. And then, of course, transmission media for us would be air transmitted, and then I have to take it from this 80 to 110 megahertz and bring it back to where the human hearing between 0 and 20 kilohertz can hear it. And that's where we do demodulation. Okay, so the rest of this conversation related to communication would be talking about, okay, for different schemes like frequency modulation, FM, amplitude modulation, AM, what happens, how do we do the modulations, and all of those kind of goods, and how do we do demodulations and all of that. That brings us to the end of the introduction part of the communication systems.